It's homework time. Here we go. Happy. Homework time. Lesson 14. Let's do it. Start in the right way. Put your name at the top of the paper. I'll write my name and you write yours. And then let's put today's date, because anything worth doing is worth doing well. All right, today you write the actual date where and when you are in this wonderful world of ours. We're going to use Redoux to solve the following problems, that is reading, drawing, and writing. So let's read. Molly, bless her heart, baked a pie. You know, people are always doing this kind of stuff in Eureka Land. They're making crafts, they're baking. It's a beautiful place. So she baked this pie for 1 hour and 45 minutes. Then she baked, oh, she's not done, banana bread for 35 minutes less than the pie. Our question is, how many minutes did it take both to bake the pie and the bread all together? Now, we have a comparison going on here, and that's why it's helpful to make two tapes. And so we'll have one for the pie and one for the banana bread. So our pie we know is 1 hour 45 minutes. We'll make about yay. And then we'll make our banana bread is 35 minutes less than the pie. So it's going to be about yay, I don't know. We don't know. I don't know, you don't know, we don't know, because we haven't done the math yet, but it's less. So the pie here is pretty straightforward. That's 1 hour 45 minutes. And what we know is that the banana bread, that's the difference here that we're given. We're given the difference is 35 minutes. And so what we're trying to find is the two of them together. And we'll call this, well, we already used B, so we use T for tasty treats. All right. And we can actually do this math, this part of it here pretty simply. It's 1 hour 45 minutes here. Maybe we can squeeze it in here. 1 hour 45 minutes. Ooh, it's going to be close. Minus 35 minutes equals, well, this is one of the rare instances where we don't have to do a whole bunch of decomposing and composing and recomposing and uncomposing and anti-composing and just do, okay, well, it's going to be 1 hour and, yeah, 10 minutes. 1 hour, 10 minutes. And our question is the two of them together, so we can actually, there are different ways of doing this, but we could just add these in a straight up vertical form. 1 hour, 45 minutes, 1 hour. 10 minutes, because I looked into the future and I saw, wow, this one is not so complicated either. An hour is 2 hours. 45 minutes and 10 minutes is 55 minutes. And for a second I'm thinking, geez, I must have done something wrong. That was like almost too easy. There was no big recomposing thing to do. I say, oh, okay, it's number one, that's why. So we do just still need our statement. It took Molly, bless her heart, 2 hours, 55 minutes to bake. I'm just going to say both. You could write the pie and the bread if you want. Woo! Yeah, feel good. Number one, done. Let's go on to number two. Baking, crafts, class parties, making punch, and going on the playground and messing with fish. Those are the kind of things that people do in Eureka Land. So a slide on the playground is 12.5 feet long. Okay, so just think about that for a quick second. 12.5 feet long. Okay. Now it is 3 feet 7 inches longer than the small slide. So how long, our question is the small slide. And so we will use L for long, and we're going to do two tapes because, again, this is comparative. We're saying this is more than this, less than that, shorter, longer. Okay, so we're going to have long and short slides. Okay, so our long one is, you got it, longer. So do, boom, do. And then this one is the shorter slide, so it's going to be, boom, yeah, shorter. And about yay, about shorter, because we don't know exactly yet. All right, just make it shorter. And so this is 12.5 feet and let's just take a moment while we're here and think, well, half a foot, well, if 1 foot is 12 inches, what's half of 12 inches? You got it. It is 6 inches. So this is 12 feet, 6 inches, okay? And now this one is what we're trying to find. So I didn't do it on the last one, but I could put a question mark there. What we know is the difference between them. And the difference is 3 feet, 7 inches, okay? Because the longer slide, okay, you see, all right, good. So now our question is the shorter slide. We're not looking for the two of them together, so I'm not doing a bracket to put them together. Always make sure there's something my students, sometimes forget is to say, okay, well, what's the question asking? And to mark that in the tape diagram. And so in this case, that's why I put this little question mark here. What are we trying to find is the length of the shorter slide. So we can see if we take the length of the longer slide, which is 12 feet, 6 inches, 12.5 feet. And if we were to subtract the difference between them, that would give us the unknown part, the length of the smaller slide. Now, we notice here, what do you see? Yes, is that we are going to need to decompose / regroup here in order to do 6 minus 7, right? If it were the other way, okay, it's not though. All right, so we'll leave 11 of those feet alone. And there are different ways of doing this. This is how I choose to do it today. And then we take that 12 foot and decompose it into 12 inches with the 6 inches already present. 12 and 6 make 18. So 11 feet, 18 inches is the same as 12 feet, 6 inches. We just, okay, you got it. All right. And now we can subtract the 3 feet, 7 inches. And what do we get? Well, 11 feet minus 3 feet leaves 8 feet, and 18 inches minus 7 inches is 11 inches. Very good. And so now we just need a statement. That's our answer. That's the length of the shorter slide. So the small slide is what they call it. The small slide is 8 feet, 11 inches long. Boom! Oh, look, we're not done here. Number 3, the fish tank. The fish tank. Whose fish tank? Oh, look, it's Jeffrey. Return of Jeffrey. Sup, Jeff? The fish tank holds 8 gallons, 2 quarts of water. Jeffrey poured 1 3/4 gallons into the empty tank. How much more water does he need to pour into the tank to fill it? Well, Jeff, maybe just keep pouring until it looks full. All right, we'll do the math. Fine. All right, so what we have here is we have a known whole, and we're looking for a part. Now, could you draw 2 tapes here? You could, but I think it's more effective to draw the one because this is the whole fish tank, okay? And so we know, and for once I left room on top for a bracket. Oh, and then I made the bracket too big, so I had to squeeze it in anyway. All right, so the whole fish tank, the whole fishy shebangy is 8 gallons, 2 quarts. And we know he poured in a certain amount, and we see it's relatively paltry amount, isn't it? 1 3/4 gallons is what he's poured in, and yes, I realize that 4 is imperfect. So he's only poured in this much. And so this is what we're trying to find here, and I'll mark it with a question mark. I could do a bracket and call it G or whatever. 1 3/4 gallons, though, is in a different format than the gallons and quarts we have here. So let's make things the same so it's a little easier to work with. When we look at 3/4 of a gallon there, yes, how many quarts in a gallon? 1 gallon is equal to 4 quarts. So that's rather convenient here because that means we have 3 of the 4 quarts. So this is equal to 1 gallon, and 3/4 of a gallon is 3 of the 4 quarts. It's 3 quarts. Beautiful. And so now you can see we know the whole, we know a part, we're looking for an unknown part. That indicates, yes, subtraction. So let's subtract 8 gallons, 2 quarts, and we're subtracting the known part, the 1 gallon, 3 quarts. Oh, and we see right off we have to do something here. What is it? Because we can't say 2 minus 3 is 1, because that's backwards. All right, so of the 8 gallons, we'll leave 7 alone. So 7 gallons. And then that 8th gallon we will decompose into quarts, and 1 gallon equals 4 quarts. Combined with the 2 quarts already present, 4 quarts and 2 quarts is 6 quarts. And now we can much more easily and capably subtract 1 gallon, 3 quarts. What do we get? 7 gallons minus 1 gallon leaves 6 gal. Hey gal. 6 quarts minus 3 quarts leaves 3 quarts. Very good. So now we just need a cute little statement. Jeffrey needs 6 gallons, 3 quarts more, and you could continue that sentence, to pour into the tank to fill it if you like. Well, I'm done. Hey, we've already rounded the midpoint here. Let's go on to number 4. Yeah. And now in this one, we're back to delectable delicacies at the candy shop. The candy shop which has no name. It's just a candy shop. There's only one. And they put 10 ounces of gummy bears in each box. Okay. How many boxes do they need to fill if there are, weird use of the passive voice because there's no humans in this question, how many boxes do they need to fill if there are 21 1/4 pounds of gummy bears? Okay, so let's look at this. We're dealing with ounces. We have, underline, it's 10 ounces in each box. Our question is how many boxes, and we have 21 1/4 pounds. Okay, so there are several ways we can go about this. We do need to draw, but our drawing is not going to be that useful because basically we're going to have a tape that is, well, I say it's not that useful, but I take that back. It will show us what we need to do. And so this is 21 1/4 pounds. That's what we have, right? And now what we're trying to find out is, okay, if we do 10 ounces, there's a box, and then 10 ounces, there's a box, and then there and there and there, and there'll be dot, 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 dot. Okay, so how many boxes can we get? And this shows that we don't know, that we're trying to find the number of boxes. So I can put here, that's not a hashtag, that's a number symbol, number of boxes. That's what we're trying to find. And this shows that we're going to be dividing. Now, we cannot take, however, 21 1/4 pounds and divide it by 10 ounces and get anything resembling a correct answer. We need to be talking in the same terms, and here it makes sense, I believe, to put the 21 1/4 pounds first into ounces. Okay, so 21 pounds, and now look at the 1/4 of a pound. How many ounces is that? Well, let's do it out just to make sure we're thinking straight here. Okay, if we want to put that into ounces, it's 1/4 of a pound. I don't know if I said that right. How many ounces is it? So it's 1/4 of a pound. Well, it's just equivalent fractions. We did this in the last lesson. 4 times what is 16? 4 times 4. So if we take 1/4 of a pound, multiply it by the equivalent of 1, 4/4, that'll tell us how many ounces it is. And 1 times 4 is 4. So 1/4 of a pound is 4 ounces. Now that's a step in the right direction. However, it does not enable us to do the division just yet because we have this 21 pounds. We need ounces. So if each pound has 16 ounces in it, we need to do 21 times 16 ounces per pound to know how many ounces that is. Okay, now if you recall how to do standard algorithm here, go for it, brother. Go for it, sister. What I'm going to do with you instead is break it down into 21 times 10 and 21 times 6. Right? And I'm going to take the time here to show you that what we're doing here is 21 times 10 plus 21 times 6, and hopefully that looks familiar because that's the same thing as 21 times 16. Okay? Good. And the reason we're doing this is because 21 times 10 is a little bit easier to do. We just ride that time 10 slide and we know it's 210, right? Recall that? Good. All right, and then 6 times 1 is 6. 6 times 2 is 12. And then we can put these together. And what do we get? Well, we'll write it out in vertical form so we can see it. 210 plus 126. 0 plus 6 is 6. 1 plus 2 is 3. And 2 plus 1, likewise, is 3. So it's 336 ounces. Not so fast. What we forget, or not forget? Yes, we have those other 4 ounces here. So we have to add in those 4 ounces. 336 plus 4, yes, is 340 ounces. Yes. Now that's the total number of ounces. That's equal to 21 pounds, 4 ounces, or as we were originally given it, 21 1/4 pounds. Okay, I know I'm taking my time on this, but I really want you to understand it. So don't leave me comments saying, you talk too much. I want you to really understand this. And now, in fact, so badly do I want you to understand this. Now I'm going to go back and do 21 times 16 in the standard algorithm. 6 times 1 is 6. 6 times 2 is 12. We're going to the tens place. Thou shalt have no ones. Yes. 1 times 1 is 1. 1 times 2 is 2. And when we add these up, you will not be surprised that we get that same 336 we got by breaking it down using the distributive property. Okay, so 340 ounces is what we're dealing with. That's what we have in gummy bears. We're going to put 10 ounces in each box. So if we take 340 and divide it, quite literally, into 10-ounce boxes, divide it by 10, that will tell us the number of boxes. Yes, now we're writing that divided by 10 slide backwards on the place value chart, right? So, yes, it's 34. Remember that back from modules 1, 2, 3, and 4, 1, 2, and 3? So it is 34 boxes, and our statement will say exactly that. They can fill 34 boxes. Exclamation point. Huh! Guess what? One left to do. Let's do it. I swear I can picture them writing these questions late at night when they got a wicked case of the munchies and they're like, I could go for some gummy bears. Oh, no, wait, brownies. Mom, whoever she is, somebody's mother, she can make 10 brownies from a 12-ounce package. Okay, so now we have 2 questions here. How many ounces of brownie mix would be needed to make 50 brownies? Okay, hey, that's not so bad, because think about it. So here she goes, and this is, let's call this this is 10 brownies. And it's 12 ounces. So now if she wants to make 50 brownies, that's 5 times as much, isn't it? So if we make a tape that is 5 times as long, I'm going to draw 4 lines here. 1, 2, 3, 4. So now this is 5 times as long. So this would be, oh my goodness, what a horrible bracket. Come on, do better, man. Yeah, okay, 50 brownies. We can actually see exactly what we need to do. It's going to be 12 ounces, 12 ounces, 12 ounces, 12 ounces, 12 ounces. Yes, so it's 12 ounces times 5. We could do this in our heads by working backwards. Watch this. 5 times 10 is 50. Hold on to that. 5 times 2 is 10. 50. And 10 is 60. 60 ounces. So, Mom, can Can't write and talk at the same. Mom needs 60 ounces of mix to make 50 brownies. Go, Mom, make your brownies. All right, now, so she can buy the 12-ounce package, but she's like, you know, I'm making so many brownies, I should buy that bigger 1.5-pound bag of brownie mix. Brownie mix is also sold in 1.5-pound bags. How many bags at 1.5 pounds each will be needed to make 120 brownies? Whew, man, this is quite, when they say extension, they mean you're going to hurt, kid. All right, so, but we could do this, watch. All right, so our tape is going to be one of those ... deals because, again, we're going to put brownies on top. She wants 120 brownies. Okay, and now it still takes 12 ounces to make the brownies, but what we're looking at now is 1.5 pound bags. 1.5 pound bags. And what we're trying to find is ... how many of those we'd need. Okay, so what we need to do is think in terms of 12 ounces because this is still true up here. The 12 ounces makes 10 brownies, okay? So we could even look at this and say 1.5 pounds is, let's talk about that in terms of ounces. Half a pound is half of the number of ounces in a pound, which is 16. There are 16 ounces a pound. So half a pound is half of 16, which is 8. Very good. So 1 pound, 8 ounces, which we could also say is, well, the 1 pound is 16 ounces plus 8. Okay, so 24 ounces. Ah, that's going to work out pretty well, isn't it? So one of these bags at 1.5 pounds is actually the same as 2 of these 12-ounce packages. We see that? All right, so now each bag is 24 ounces. We've gotten that. And so now our question is, how many of these will she need to make 120 brownies? So think about it. 24 ounces will make how many brownies? You see it? 12 ounces makes 10. 24 ounces, twice as much, will make twice as many brownies. So it makes 20 brownies. And there are different strategies we could use to solve this, but this is one I think makes sense. So that means, yes, how many of these would we need? Well, we know that 6 times 20 is 120. And so how many of these bags would she need? She'd need 6 of these bags. There we go. So Mom needs 6 bags to make 120 brownies. And that one was an extension because it was more of a logic problem than really a math problem. Oh my goodness, look what you just did. You just finished your homework. Nice work. I'll see you again next time. It is once again homework time.